We will now look at two of the most popular types of machine learning tasks. These are classification and regression. And these types of problems are so frequent that the large majority of our course will be dedicated to just these tasks. So please make sure you understand them. We'll first look at the classification task, which is the most popular task in machine learning. Now, classification, we have a classifier, and its job is to take an input and then produce an output label. We can also look at this as a function where the input is, could be any document, could be an image, could be a document, a text, a signal, and it outputs a label y. And this y is a discrete or categorical variable. Now, here are some examples of classification. So here we have two x-rays, and we want to try to predict whether this x-ray shows that the patient has pneumonia or not. Another example, is this image photoshopped or not? You can also do things with videos, like predicting the action in the video. For example, dribbling basketball. In natural language processing, you have a spam filter. Is this spam or not? You can also do things like fake news or fact verification. So in this case, we are trying to verify that this claim is false. There's also hate speech detection, whether this text that you see is a potential hate speech. And we can also have audio as an input to predict whether this is a hip-hop song, or pop, or country, or some song that my grandpa listens to. Okay, so there are a few types of classification tasks. So the easiest task is a binary classification task, which means there are only two possible labels: yes or no, true or false, dog or not dog. Then we have multi-class classification, which means you have more than two labels to choose from. In this example, we have 5 possible labels. And the classifier will have to choose the one correct label. We also have multi-label classification, where you have multiple possible labels, but then there are more than one possible answer. So in this case, there could be 2 answers. The picture shows both a cake and a dog. So this is an image of both a cake and a dog. Now, look at the second one, which is regression. Now, regression, we have a regressor. And similarly, we have an input, and output is a label, but this time the label is a real valued float value. And just like classifiers, we can write it as a function that predicts a y, except y now is a continuous real valued number. So, some examples of regression. For example, you have given the size of the house, predict the price of the house. This is called simple regression. There's one possible variable as the input and one possible variable as an output. You can also have another task with multiple inputs and predicting an output. So this was an example from earlier. That was actually a regression task. Here, this is called multiple regression, where you have multiple input variables and one output. And here's an example. This time the input is an image, which means it has multiple variables. The output is also multiple variable, where you try to predict the bounding box. of the umbrella. X and Y would be, for example, the top left position of the box, and W and H is the width and height of the box. So this is actually also a regression task. And more specifically, this is called multivariate regression, where you predict multiple output labels. And so, if you ever look at this kind of images, you can say immediately this is a regression problem. And we have as the input time in this example, and the objective is to predict the value given the time. So this is a bad regressor because it doesn't really do well at all. Here we have probably a very good predictor, so given the time, you predict the value. Of course, we are expecting a lot of errors because this is continuous, but this is a good predictor. In the third option, you see, it does really well. In the training set, you can predict everything, almost everything correctly. Problem is, will this work well in an unknown new example? So if a new test example that we have not seen, would this actually generalize well? So that is a very big question. So as a summary, classification is where you learn a function, given an input, predict an output label, y. And the label is a discrete or categorical variable. Regression, we have the same function predicting a label as well, only y is real valued or continuous. Okay, now we will focus on the supervised learning problem, which is usually the most common type of setting in machine learning problems. We will discuss the pipeline of supervised learning in the context of classification and regression tasks. These are usually, but not always, supervised learning tasks. You can technically still perform classification or regression without using any example correct output labels. But we assume that these are supervised learning problems and proceed with that assumption. Okay, now before we start, I would like to play a game. The game is called Are You a Good Binary Classifier? Yes or no? So, let's say I showed Antoine 10 shapes. And I asked Antoine whether he liked each of the shape. And here is his answer. Now, I've suddenly been given 3 new shapes, which I didn't ask Antoine before whether he liked it. And unfortunately, Antoine is not available for me to ask at the moment. So, can I get you to help me determine whether Antoine actually will like these 3 shapes, depending on what you saw earlier, with what he annotated before. So, try this. And at the bottom of this page, there should be a Mentimeter link, which will take you to a nice interface where you can actually vote. And we'll look at the results during our live session. So, try this. I'll see you in the next video.